Hello everyone, my name is Brian Scholes and I'm Event Manager with AusIMM, and I'll be facilitating today's webinar, Setting Studies Up for Success. I'd like to thank you for attending the live webinar today and those who are viewing the recording. Just a few housekeeping items before we get started. Everyone is on mute today to avoid presenter distraction and noise feedback. We will have time for questions at the end of the presentation. Should you want to ask any questions, you can type them into the question box available to you on your side panel. A copy of the webinar will be sent via email to everyone who is registered in the next few weeks. We also have a quick exit survey when you leave the webinar. I'd now like to introduce today's presenters from Ausenco. We have Matt Powell, Global Technical Solutions Director, Andrew Hoyle, Study Manager, and Duncan Dodds, Study Director. Over to you, Matt.
Thank you, Brian, and thanks to the AusIMM for hosting this webinar on our behalf. And thank you to everyone who's joining us for this webinar. We hope you find it quite interesting and useful. Please, as Brian mentioned, enter your questions into the chat box as we go. We'll have a bit of time left over at the end to go through those, any questions you might have. So this is the second webinar as part of a series of webinars, and what we're doing is we're looking at the whole processing value chain from exploration through to market, and how that's changing over the last 5-10 years, and what it will look like over the next decade and moving forward. And really, we're looking at how the sort of production landscape's changing and in concert with the social and environmental landscapes, and how that's changing the way we do projects. This webinar is a 6-webinar series. The first one was a couple of weeks ago, hosted through AusIMM, which you can go back and take a look at if you're interested. And it provided a bit of an overview and introduction to how the landscape is changing, those drivers I just mentioned. And this webinar is talking about studies. Subsequent webinars will go through and talk about the rest of the project lifecycle through to from design through to optimization. So studies is a topic that I'm particularly passionate about. About 4 years ago, I was working on a project that had a capital cost of about 400 million. It was based on inputs that were provided by the client and test work that done for a certain flow sheet that was actually metallurgically quite neat. It got quite high recoveries, but it was complicated and expensive. We commissioned this project actually recently, but between the initial capital cost estimate, we went back, reevaluated it, and reduced the cost. We actually reduced the cost from 400 million to 6 million. So we reduced the capital cost in the process plant by 98%. We challenged the paradigms on how the original study was framed and came up with a very different approach that used existing equipment that was largely on site and unavailable. So that's the sort of potential, not all the time obviously, but that is the difference that a good study can make, and that's really what we'd like to focus on today. Specifically, we'll have 3 presentations. The first will be by Andrew. He will talk about what does good look like for studies, and that's really knowing about what the destination is and how you're going to get there. I'll extend on that and talk about the importance of economic modelling, which is sort of steering the steering wheel to keep the project on track. And Duncan will talk about successful study outcomes, making sure you get it right. So I'll pass over to Andrew to talk about what does good look like for studies.
Thanks, Matt, and good morning, everyone. As Matt said, in the next section, I'm going to talk about what good looks like in studies. So when I was first asked to present on this topic, I was actually reminded of earlier in the year when I was working from home, and during breaks from homeschooling the kids, they introduced me to a show on Netflix, which is called Nailed It, and it's a cooking show. For those of you who haven't seen it, the premise is that contestants are shown a professionally made cake. They're given a recipe, they have quality ingredients and professional grade equipment, and of course they have sufficient time to prepare this cake. So at the end of the show, the efforts of the contestants to reproduce the cake are shown, and there's quite often hilarious results. And this got me thinking. Now, despite having access to the best equipment, quality ingredients, professional advice, and having sufficient time, why do the contestants fail to replicate the cake? And I think this has a lot of parallels with developing studies. studies. It's too common that you have all the ingredients required. You have sufficient time, you've got allowances for the cost, you have equipment, drafting equipment and other tools to develop your study. You have professional advice. And of course, everyone has access to the PMBOK recipe for how studies should be run. However, lots of studies fail to achieve good outcomes. So I'd just like to preface my section to say that this webinar is not really about a recipe for success. I'm going to try and offer a series of tips and recommendations to assist in achieving good study outcomes. So in Asenko's experience, successful studies have a number of common elements. And the first that we've seen is that study goals really need to be communicated within the project team, and they need to be aligned to a measure of value for the project. The next element you require is that you have to have an economic appreciation of the project, and you have to understand what success looks like in terms of the economic drivers for that project. So, of course, as part of studies, everyone's dealing with a number of options, and to be an effective study, options need to be analysed and eliminated at the minimum level of detail, which supports the differentiation between the options. And as you see in the previous example of the cooking show, having an team and a good quality team is a very important part of study success. And it's paramount that you compile a team that actually knows what good looks like for the scope in question. And this team needs to have the skills to actually perform the study. We shouldn't have a team that's learning on the run. And to be honest, in this area, cheap is not really a good foundation for success. So the team needs to have an environment where they can listen, challenge, align, build trust, and deliver on time at all stages of the study process. And if you have that, that allows them to challenge the process in the concept phase, challenge the design in the PFS, and challenge the detail of the engineering in the FS, and ultimately set the project up for execution success. So to frame what we're talking about, what is a study? And when we refer to studies, at the most basic level, we're talking about a process of answering a question about what the project should look like. In the early phases of studies, there are a number of diverging stages where you start generating ideas of what this project could look like and generate questions that you need to answer. Ultimately, you need to pull that in and start converging onto what the facility is going to look like so that you can start engineering the project in more detail. And of course, the outcome of the study is having a feasible project which can proceed to execution. Now, the project management tasks will split up studies into a number of different staged approach, which are purely for management. And we all know the names as desktop, PFS, concept studies, feasibility studies, or the FEL levels of study. So the first question I'd like to ask is why is a good study important? And research has shown that early phases of the project have the greatest ability to affect the final project value. And this is the case, even though the engineering in these stages is often a lot less detailed. So as the project progresses throughout the study phases, lower amounts of value can be added due to the fixed assumptions and higher cost on schedule and implications of rework. So change in the execution stage often results in value destruction due to the effect of schedule and the rework required while you're actually trying to execute a project. So research has shown that good studies with poor execution can still develop higher levels of value than poor studies with good execution. And so it's important that we know what the goals for the study phases are as these will guide what the project looks like and the ultimate value that you can deliver. So what should the goals look like in study phases? I've reviewed a number of studies that were successful that I've been part of, and I've found that the goals for each of these studies were different. Some of the projects were looking to implement a low capital approach, while others were targeting low operating costs. And even others still weren't focused on costs. They were just after a quick, easy implementation of the project. So each study can have different goals and they can consist of a number of different things. However, I've found successful studies all have one common goal, and that is that the goals have been chosen and they're communicated. And then there's alignment within the team and within all key stakeholders. So whilst the goals chosen for each study may be different, they all align to providing maximum cash flow at minimum capital, especially when accounting for the risks of the project and the schedule. So once we have our goals set and communicated, we move into carrying out the study. And when you first start the initial diverging stages of the project, you really need to focus on decision making and risk mitigation. To make decisions, you need to focus on relative rather than absolute answers, as this is at lower levels of engineering. You need to analyze the options at the minimum level of detail possible so that you can differentiate them. And really the key is not to seek perfection. Challenge your paradigms and rely on your experience and benchmarks rather than developing everything from first principles. So once you've set the overall value proposition, the focus then moves to higher levels of details and precision so that the project can be executed. Look, there's still scope to optimize value within the later areas of the phase of studies. However, these value improvements are smaller in value and should be checked to ensure they're not destroying value in the overall project. So an example of late stage value improvement that I've seen in a project I worked on was trying to reduce the grind size in the process plant to gain some marginal recovery. And at this point, we had to do a bit of a check because the TSF was being built out of the sands from the tailings. So it's important to understand total value, because while we were gaining revenue in improving recovery, we were going to have to spend a lot more money on the tailings dam, which would have ultimately destroyed value for the project. So to achieve good study outcomes, the study team needs to understand the question that they're asking for the project for that particular study phase. Now, it's particularly important for clients' teams to put together scope of works and RFPs to understand what they need to achieve from the study. If at the start you don't understand what trade-offs you want to achieve and what you want to look at, it's likely that your engineering consultants are not going to perform well. They might not even have enough allowance in their costs to achieve some of these studies. So it's important that you sit down, and we've performed framing workshops in the past, which helps come up with what are the key questions for the study at this phase. So you need to know how you're going to get to the end point of the study. You need to have alignment within your team about what you want to achieve. There's no use people going off on tangents. And you need to ensure that your results during the study are integrated between areas to prevent local optimizations which impact overall value. And it can help for your study to determine the level of detail and the method you're going to use to track value so that you can steer the study in the right direction during the study rather than doing the capital cost, operating cost check-in at the end of the study and realize you're actually at the wrong destination. So is this what a typical study looks like? And unfortunately, many studies look like this, where the correct decisions are not made for the project in the early phases, and they result in unchallenged assumptions and unmitigated risks. And then when the project reaches feasibility, it's unable to be permitted or unable to receive financing. So often at this point, the project team goes back to the drawing boards and they upgrade the FS using some value optimization tools. However, this normally results only in incremental project improvement and doesn't change the fact that it's not going to achieve investment hurdles. So ultimately with these projects, they require a review at conceptual level to challenge the assumptions and to improve overall project value. And in the final section of this webinar, Duncan's going to show you how we've created value in projects which previously had uneconomic outcomes by going back to conceptual phases and reviewing the underlying assumptions on the overall value chain. So we've mentioned previously that team is very important. Just like the cooking show, if you don't have experts and people who are proficient, it's going to be really hard to get a good outcome. So there are a number of key points here that we've put together on how to get a good team. And first point is really around, everyone in the team really needs to share in a mutual risk and reward of the project and share in success. This is probably an area where some new methods are required, because at the moment for engineering contractors, sometimes the reward is more engineering hours, which doesn't really lead to valued outcomes. So it's important that everyone can share in the success and the risk of the project. Now, the owner's team and the contractors also really need to have share a key focus and alignment, and they need to have trust in each other to deliver on the project. And this is really gained through having effective communication and having a safe environment. And that'll allow all the assumptions to be challenged and lead to the greatest project value. So the team really needs to have a diverse skill set, and learning on the run should be avoided. And too often teams are chosen because of technical excellence. However, I would argue within successful projects, all team members need strong management competencies, and technical expertise is not going to be enough. So I'll end this section with just a few points of study traps which I think should be avoided. And it's easy to simplify studies and focus on a recipe from the project management approaches, managing time, quality, and cost. However, there's always problems if you get the mix wrong. Studies that are focused purely on cost usually end up having big problems. You're either focusing on cutting down the cost of the study, which leads to poor engineering outcomes, or if you're focusing on purely a lowest cost design, you might be missing value. If you're focusing on schedule, it may lead you to progress these studies to higher level of detail, even though you haven't met the outcome. And the same if you're strictly adhering to schedule, you might not get the value out of the work that you're performing at the time. So, and the final one is you shouldn't really wait until the study's complete to review the financial model and the capital estimate. You need to review that and make some assumptions along the way. So I'll now hand it over to Matt Pohl, who's going to talk about the importance of economic modelling.
Thanks, Andrew, and thanks for touching on the importance of economic modelling in your talk. For those on the call, it is such a critical part, is the reason that we've broken it out as the second section of this webinar, because it deserves its own time to explain. So over the next 5-10 minutes, I wanted to give you some background into the importance of economic modelling. Why is it important? What are the keys to successful economic modelling, i.e. how can you do it well? What does it look like at different study levels, because it's certainly not the same. The questions that we're asking at different study levels are different, and therefore the approach around the economic modelling needs to reflect that. And then finally, if you have an economic model, what can you do to drive value from it? So firstly, well, why is economic modelling important? In the framing stage of a study, it's really important to understand where your study sits, because not only does it drive the outcomes for the project and what the project might look like, but it drives how the study should be executed to ultimately get there. Now, back in 2010, 2012, we had some pretty high commodity prices, and I'm showing this in the graph on the right-hand side. And we've seen a couple of projects come across our desk lately that maybe didn't go ahead in that time, but we've been asked to review them and maybe update the studies and things like that. When the commodity prices are high, the drivers for conducting a study and a project are very different. We're seeing that at the moment with high gold prices, where really there's less emphasis on delivering a low capital cost project compared to just delivering the project quickly. Then if we move into low commodity price markets, which is effectively where we were maybe 3 or 4 months ago, the copper spot price was quite low. Some of the projects that look quite good around 2010, 2012, and this is what I'm showing on the bottom right-hand side graph, you know, that the payback might have been 2 or 3 years at a high commodity price. At a low commodity price, the payback is maybe 6 or 7 years, which is really going to struggle to get any financing. So the point is that a very rough economic model, even to begin with, just considering the assumptions around price, gives a lot of direction into the project itself and how the study should ultimately frame that project. If you build into that the ore body characteristics and a little bit about it, the mining and processing, that's really you know, based on benchmarking, that's gets you a long way down the path. Yet we still see studies come across our desk that haven't considered these basics when the studies are going out to market. So economic modelling is a way to define and understand the knowns and unknowns. So when you develop an early economic model, you are putting in a lot of assumptions there. Really, none of the numbers have been tested. A lot might have been benchmarked. A lot of people might have off the top of their heads that have been in the industry for a while. And really, the economic model is a really good place to test the sensitivity to those assumptions, determine the risks, and the unknowns become the gaps in what needs to be studied. It's a very good tool for decision making. So the right economic model, considering the right scope at the right level, can support or reject decisions. And then as you get towards the final stages of a study, it's a tool for financing. So ultimately, the economic model purpose changes, and the bankers and other lending institutions will want to build in the financing structures to reflect how much capital is going to come from direct lending from banks, how much is going to be equity, and put those debt structures into it. So the keys for successful economic modelling are, you know, as Andrew pointed out, it's really important to develop the financial model early and refine. There's a conventional approach that, again, we see within industry far too often, which is a study will be scoped, engineered, costed, and that process in itself can be 6 to 12 months, depending on the level of definition. And it's only towards the back end of that study does the loop get closed on the economic modelling to find that, well, we've got a study that isn't very good or doesn't look attractive, and then there's generally another phase of work to try and reshape it within a relatively short period of remaining time to get it acceptable. You know, a much better approach that we use is early on benchmarking, using experience based on previous projects, develop target cost estimates, and continually refine the level of definition in the economic model so that it's able to achieve its purpose of enabling quick decisions and driving eventually to a robust economic project. So it's important to build the model at the right level. It's important to include the whole project in the model, not just certain elements of scope. As Andrew indicated, a grind size recovery relationship that doesn't include the impacts on tailings or maybe power supply and infrastructure could really come up with completely the wrong answer. It's important to focus on the right measure of value. And more recently, we're seeing studies, and we're making sure our studies don't just look at an NPV or maybe an NPV on capital cost or whatever metric the client wants to use, but that includes a consideration of risks and consequences. And in the current landscape, that's becoming more and more important. Overall, it's important to understand where the step changes are in various costs. And again, use the sensitivities around the economics to work out if a technical area needs further definition. We have done projects before that have been developed and successfully developed on very little test work. And the reason is simple. If the results are within a range and there's good confidence that even worst case results give very good financial outcomes, then potentially you're actually just eroding schedule by going and conducting test work and filling in gaps. So to talk about how the economic modelling changes for different study levels, as I mentioned, there's very different purposes of early on economic modelling at desktop levels to economic modelling to support a feasibility or financing. At the desktop level, our models, we tend to combine the technical and the economic aspects in the one model. And it allows us to be quite powerful in the way we consider a whole wide range of options. The estimates are factored based on in-house data or maybe early engineering, and we can, I guess, really throw a number of darts at the dartboard to see which options are looking good and which ones where the sensitivities sit and where the project might sit overall. As you go into the next level of detail, somewhere in the middle, maybe as you start to converge, the time phasing becomes more important, and sometimes time phasing is more important early if it's a very short life project. So we then start to build in that additional level of detail around the cash flow profiles over the life of mine. And then as we get into feasibility study, the economic models are multiple tabs within a sheet. They're quite detailed. They're looking at capital and operating cost estimates in a fair bit of detail and breakdown, and there's much more engineering definition that goes into those on a few specific cases. It goes without saying really that by the time you're at a detailed economic model, running lots of iterations on that model is time consuming and difficult to do. And if you do try and do it, you'll probably find that by the time you get to the answers, the study's moved on anyway. So it's really important. The point here is that there's a right level of economic modelling, and it's important that the whole study team is aligned about accuracy and really what you're trying to achieve, particularly in the early levels. So once you have an economic model, how do you drive value from it? It's important to optimize the process and infrastructure together, the whole project. So you need to look at the different mining methods, what the different value sources, there could be a whole range of them, whether you're looking at byproducts or retreating old tailings dams or waste dumps, or maybe open pit and underground sources or satellite deposits. There might be a whole range of processing routes, and some of those might be deferred because they generate less margin initially, which is where stockpiling and blending comes into play. Infrastructure for new greenfields projects is incredibly important. There's a whole range of iterations that happen around infrastructure to try and align throughputs of plants with the total project. There can be certain constraints that are set. Sometimes you have to make assumptions early on before you can sort of jump on the merry-go-round and start crunching out decisions, but it's important to go back and challenge them. If they were made very early on, well, are they real, and could they actually unlock some value? And that was similar to the example that I discussed earlier. There might be step changes, and understanding where they are is really critical. It might be in a power supply or a mill technology if you go above a certain motor size, or from one line into parallel lines. And I guess getting the right level of detail around those key decisions into the one model early on can be really useful. And sort of looping the economic discussion back to what it means for different projects, the differences are quite stark, and it's important that everybody working on different projects, from the study manager through to engineers and drafters and graduates, understand the context of the study and the project on the overall economics. And I'm showing two examples here. One is for high value material. So if we considered a low throughput, high grade, selectively mined underground deposit, we find that most of the project centers on the mining aspects, in that the mine development costs are high. The cost per ton to mine is generally very high. You can be mine limited, and really the design of the plant in that instance can push to maximizing recovery as a better overall project. Minimizing capital and operating cost is always important, particularly capital if there's a financing constraint. But sometimes and there's been a few of these that we've seen lately, very high grade deposits, capital cost, you can get away with slightly higher capital costs, although it's not what we try to do. The projects can still support higher project capital costs. On the other hand, if you move to large deposits that are maybe lower grade, the mining methods are much cheaper and more bulk, it's really important that the capital costs are spent on the constraint, and that the highest capital cost item is constraining the project. That's almost what centers or grounds the project. The goal is to maximize throughput, reduce operating costs, reduce capital cost, and try and push revenue through those circuits. So the driver is very different. You may be willing to sacrifice recovery for those styles of projects. And I guess for both projects, we're finding that there's new approaches. I guess the way that we've described today is not a new approach, although it's not done all the time. But taking this style of approach is important, as well as new technologies, some that were discussed in the previous webinar. For those that missed it, you can go back and have a look. But things like pre-concentration are genuinely giving step changes in project economics and making marginal projects more viable. So I'll now pass to Duncan, who will talk about successful study outcomes.
Good morning, everyone. Before I start, I'd just like to remind everyone if they've got any questions to start pushing them through now. As soon as I've finished, then there'll be an opportunity to go through those questions. And thanks, Mary. The three example case studies I'm going to walk through were heavily reliant not only in the initial stage of the case study, but actually through every stage of advancing the study level. So, and going back to Andrew's, pretty much the whole recipe he talked about, using many elements of that all the way through each of these case studies. So I'll just highlight a few of those now. Just before I start, probably just a light moment of whether you guys can relate to this at all, but how many times have you experienced this in a study? I can say pretty much every day through my study life, and to a lesser degree through execution projects, is there's lots of ideas come up, and the key to me is understanding when to pursue that idea and to what level of detail. The guys have talked about precision over accuracy. It is about understanding what level of detail to apply to things. So moving on, the skill is weighting those ideas. So if we look at it in a whole project life cycle, once you've got some ideas, it's understanding where those ideas may give you value and which of those ideas might be addressing risks or actually generating risks. And it's really a matter of recognizing those improvements across the entire value chain. So I think, as Andrew mentioned earlier, there's no point just looking at grind size optimization in the process plant if it's going to have a major impact in your tailings dam or increasing power, in which case you get an incremental increase in your power supply. So looking at the whole project value chain is the key to a successful project. Moving on to my first case study. This first case study is a copper gold deposit in Asia. It had extensive studies already undertaken. However, it didn't actually present a value case. So as I think both Andrew and Matt presented, it got to the end of the study to find that there was no value. So they weren't challenging themselves as they were going. So the first thing that we did was understand what value really meant to the client. And to be frank, the client started with, do we actually have a viable project? Is there anything there? So we spent basically the first 2 weeks with pretty much a one-page financial model, very simple, revenue on one side, typical mining costs, typical operating costs, typical capital costs, and infrastructure costs, and came up with that we felt there was, for this deposit, a viable project. And we concluded after 2 weeks and then put a plan together how we would actually work it from there. Again, as the guys have touched on, the only way to then take it to the next step is have a group of specialist, like-minded people in a room. And in this case, we engaged with both some mining, additional mining consultants and geotechs, because in this particular area, the value chain to us was going to certainly be improved by optimizing the scale of the mine. I've put a small diagram here which shows that the previous study cases all looked at the maximum discounted cash flow and were up at the top end of the curve, and therefore the scale of the project was quite large. We identified that there was a knee point where there was a change in the gradient of that curve, which meant that the revenue dropped off sharply, yet all of the infrastructure costs and capital costs went up in the opposite direction. And therefore, that value point was the best value point, certainly as a starter project. So once we established that, it was pretty much then continuing on understanding across the whole value chain, where were the sensitivities remaining. So we now had a concept of the project. We now needed to expand the engineering, but we only put engineering into those areas that there was either some unknowns or some high risks. And we kept on evolving the level of detail till we confirmed the value that we'd set in the first instance. So the outcomes, which basically aligned to the client's initial requirements, which was we had an optimal capital intensity, which basically was minimum possible capital that still provided an NPV that could finance the project on. We had a significantly reduced disturbance, both from a community and environmental point of view. And as you can see, there was the ore body still remained there. So after the initial project, the opportunity, once all the infrastructure was in place, there was a long-term cash flow opportunity as well. So if I move on to the next case study, so ultimately we reduced the capex by 60%, which had probably one of the biggest drivers. Moving on to my second case study, which similarly copper gold project in Asia. However, this was quite different in that it had a viable case. However, it also had a number of high risks. It had significant community and land disturbance, and it was a multi-billion-dollar capex. And in the current climate, it was just too high a capex risk for any financier to take on. So again, the focus and question from us was to get alignment with the client. What did they want? And obviously they wanted a lower risk profile, something that had a much smaller footprint, much lower capex. So how did we go about that? Again, started with a simplified financial model, confirmed by going for a smaller scale mine to start with. And although that diagram on the right hand side of the pit was not this actual project, it just demonstrates that by going with a smaller pit, you can almost see the volume of waste that incrementally was reduced. So when we looked at the financial model, we looked at how much revenue would be in a smaller pit, and then looked at what capital it could sustain and what OPEX. Then by looking at the waste management strategy, particularly the waste rock and tailings, we found we could allocate all of the waste in an area much closer to the mine and pit, and effectively reduce the overall project footprint by 80%. Now again, it all sounds fairly simple, but that was only achieved by having a number of like-minded specialists in a room that were prepared to challenge the paradigms, come up with initial suggestions that took effort beyond that to prove up, or at least throw ideas on the table that look to add value. If they look to add value, then we work them to the next level of detail. Again, once we got that initial concept firmed up, it was then a matter of ongoing through each level of from scope and through to feasibility, and most importantly, continue to challenge ourselves and making sure we kept that value and we didn't destroy any. So ultimately, the success was that we had a quarter of the throughput scale, which reduced the capital by more than 75% and provided a community and environmental improvement in the order of 80% by reducing the land usage. On to my final study case. Yep. Thanks, Matt. Nice to hear there for us to take a breath. So in this final study case, again, another copper gold deposit in Asia, a bit closer to home this time though, but quite different from the other two studies we've talked about. In this case, there was no previous study work, so we were starting, as Andrew demonstrated earlier, right at the beginning of the value chain. So now was the time to really show that we could provide a successful outcome. First thing was to align on what the client's outcomes were that they wanted to achieve. In this case, they wanted a fast-track project that could support future expansion. They wanted a province-enabling project that would allow them to expand in areas that it would take them maybe 5 to 10 years to do the exploration fully. So they wanted to get started in the area before they went to the large scale. Again, we started with our financial model, and this time we just threw all the different scenarios that may possibly work from a processing and from a capex, both all the different infrastructure options. And by having a very simple financial model, we quite quickly homed in on which ones presented value, which ones were worth putting a bit more capital in because it was going to give you a bit more revenue, and which ones didn't. So once we established the scale and technology options and differentiated them, we came up with a base case. The base case was then continually retested. So once we established this through effectively a workshop with the client, agreed the single base case, then we defined all of the other alternatives that could possibly come into play if some trigger points came in. Trigger points being more drilling found that the gold grade increased over the copper grade, or the copper grade increased over, or the mineralogy changed. So we had all these points that we knew could potentially change the outcome, and we kept a close eye on them as the test work started coming in. ultimately, this required a team that was flexible and agile, because there was test work and new information coming in continually. And again, we emphasized, or we stressed within the team, to work on minimum detail so we could flex as new data became available. The key outcome was we identified a project that could get to production in less than 3 years from where we were, and it ticked all the boxes as far as a province enabling project with minimal capital, a return on investment that enabled them to trigger into a much larger project. And then really to wrap this up, so what's the right answer? I suppose in trying to summarize everything we've said is establish the best team with the appropriate experience, follow the recipe, but avoid individual goal seeking. And the reason I chose this little PowerPoint here was that what we certainly experienced, and I spent a lot of time through all of these studies, was individual area managers, technical area guys, all had the tendency to try and get to technical excellence rather than what might add overall project value. So the focus, and hence the X's, is not to focus on individual areas, but remind everybody of what the overall goal is, which is to increase overall project value. I think that's all from me now. So I think we're open to question and answers. Back over to you, Matty.
Yeah, thanks, Duncan, and thanks to everyone for listening in. I guess the 3 messages we'd like to leave you with today is, know where you're going and what a good study looks like. Andrew presented on that. Consider how important economic modelling is to steer the study and make sure you're continually going in the right direction. And then Duncan presented on some case studies on successful study outcomes, and so how it can make a big difference when it all comes together and is done right. We've had a few questions come through. The first one is, I might steer towards yourself, Andrew. And the question is, what are the biggest opportunities to improve studies that you see in the study work that you're working on?
Yeah, definitely the opportunities I've seen to improve a lot of studies is getting that work done conceptually at the start. A lot of studies, and as engineers, we want to dig into the detail. And the detail sometimes confuses where the key value within the study can be. So that's really the key benefit is understanding at a conceptual level if you're heading down that right path. And as Matt said, use of economic models in this area is very powerful. You can tell whether what scale of this project makes sense in a capital, operating, and value terms. You can see at a conceptual level where the step changes are going to occur. Where do you start spending too much money on infrastructure? And they're the really key things is having the study set up from the start, assessing the options, and ultimately knowing when your test work comes in or your ore resource changes, what does that mean to your value proposition, and what's your fallback position? So economic modelling is important there, where you might have a next best alternative that you can fall back to.
Very good, thanks Andrew. Duncan, I might direct this next one at you. It's a good question. The question is, there are constant changes in every study, and how do you manage the change, especially towards the end of the study, to minimise the amount of rework?
Okay, yeah, good question. I think the the key is, again, going back to understanding where the value in that change may be. So what I find is if you throw that into a simplified financial model again and find the value is substantial, then the answer is quite simple. It doesn't matter what level of change you need to implement, you should be implementing it because it will have the best value for the project. So, however, some value items can be kept to the next stage and therefore would have minimal overall value improvement, but have a significant impact on the work you're doing to date, in which case you look at when they would be best implemented and record them to be implemented appropriately. I suppose the final point is, this is where I personally think keeping the amount of detail you do, and certainly in the early part of the study, means that you have more flexibility to manage those changes as they come in. So focus on accuracy rather than precision, certainly in your early stages of study.
Very much agreed. There's one that's come through. How do you optimize grind size and recovery in regards to capital costs, throughput, and NPV? I might jump in on this one. Optimizing grind size is an interesting one. At a simple level, it can just be a case of saying, well, you know, what's the difference in capital cost, operating cost, to work out if it's worthwhile spending a bit more money on a mill. And you can certainly find that sometimes grinding finer overall for the project adds more value, no doubt. For certain projects, and particularly those that are lower grade, you can find that it adds more value grinding finer, but there's also a case that you can test, which is to say, if you put in more milling power, can you actually flex that to drive more throughput? And sometimes that pushes you back out to a coarser size, but at higher throughput, because that gives you more value overall. So it's one to be aware of, because you can conclude that you know, finer grind sizes and more ball mills to grind finer is a better metallurgical outcome, but maybe just driving more throughput wins again. Obviously, there's constraints to that, as Duncan spoke about, in infrastructure and maybe other factors. So there's another question, and I might put this out to Duncan and Andrew. Either of you can jump in. And the question is, how do you know if your cost inputs or assumptions are too high, too conservative? Who wants to jump in and take that?
Yeah, I can talk about that, Duncan. Typically, you know, it's important when you're looking at your cost inputs. You know, they might be high, they could be low, but it's important that you have an understanding in general terms. Are they in the right benchmark? And that's where experience is important, and generally the best teacher. So I'd recommend, you know, if you think your cost inputs are too high, that you're looking to benchmark against similar projects within the region, similar projects within the technology you're using, whether it's underground or open cut mining, and use that data to guide you know, your understanding of your cost inputs. And definitely through looking at your value model and your financial assumptions, you might find that, well, the cost of mining on this project really is affecting the value. So I need to go into more detail on that cost. And that's where I'm actually going to focus the work for the study. And the processing cost doesn't matter so much. It's in the general ballpark, but it doesn't affect the value as much. So I'd recommend that sort of model to approach your cost input assumptions.
Following on from that question, sorry, did you have something to add, Duncan?
I was just going to say, agree with that, and again, it goes back to is focus on those unknowns and risks. So once you've done the sensitivity around what that ceiling might be, if it has a big sensitivity to your financial model, then obviously focus on it and work on it. If it doesn't, then park it for later.
Very good, Duncan. I'll throw this next one at you. There's a comment first. Great discussion and presentation on the need for collaboration and open communication within groups and professionals in a project team. The question is, how do you best set up and facilitate constructive collaborative discussions between different professionals and consultants during the course of a study, such as mining engineers, process engineers, metallurgists, geologists, etc., etc.? So how do you coordinate and collaborate that, Duncan?
Great question, and with great difficulty, but I must say with great enjoyment as you go through that, because in all of those disciplines, we all have different characters as well. So the challenge I've always found is, again, having more regular discussions about what the objective is, what the greater project goal is, and sharing things like financial model outcomes with the team, so that everyone understands that their own piece of work may be one of the most critical pieces of work on the project and therefore needs a lot of effort, or maybe one of the pieces that is a foundation, but we understand it, it's a lower risk. And putting those perspectives and sharing those perspectives with the team. And then I think, again, having the opportunity to just keep challenging each other, and but doing it in a positive manner, that they understand that any ideas that come forward are not going to be blasted 2 months down the track, that in the early stages everyone's trying to put the best, most credible assumptions forward. And I think that's one thing that I've seen as a negative on many other projects, is people start talking about working collaboratively, but once they get into the project, a blame game starts. And to me, that's the key, is avoid that blame game, understand that you're all trying to get the same outcome, and share what that is. Hopefully that answers the question.
Yeah, and I think it raises an interesting thought from my side, that is, if we look at the projects of the last 20 or 30 years, a lot of them, let's say in copper, have been quite simple. Even the gold projects have been quite simple. It's been perfectly fine for mining and geos to be engaged early on, make some high-level assumptions about the processing that'll be near enough, and that's been good enough to develop good projects. But if you take that approach to maybe more modern and more challenging ore bodies, one of the issues is having mining and geos engaged well before an engineer or metallurgist gets involved on the project, which leads to assumptions being made maybe in the wrong direction, or maybe missing an opportunity. So I think one for those that manage studies on clients' teams, it's good to consider, well, how do you get the early engagement of metallurgists at the right level at the right time, so that that's all sort of happening together. The right people in the right room at the same time is probably my key thought on that.
Yeah, and Matt, I might add one more thing, which is more of a specific thing that relates to the first case study I talked about, and that was a case where it was a very close collaboration between the mining and geotech and hydro. And although we're all in different offices, we communicated very regularly. But then when the crunch came and we understood that there was some real good communication needed, we actually spent the extra dollars to pull everyone together, and we worked together side by side for a number of weeks. And again, that helps build the team. So it's about building the team as much as the outcome.
So I think we've probably got time for one last one. Andrew, I might throw this one to you. In your presentation, you said that expertise is the key to good studies and good projects. But what's the best way to incorporate the young blood, I guess, the juniors into the projects or studies so that they become experts?
Yeah, thanks, Matt. I think it's you that has the quote about project experience is one of the most important factors in having a successful project. However, the best experience comes from failed projects. And you need to have enough people within the project that know what good looks like, who've done it before, who've experienced the failures. You can't have a team of people who have never done a study. But there is a place for people who need to learn, and I think it's a really balancing act of giving, you know, the young engineers as they come through the ranks experience, as well as you know, a larger share of adding value to the project and directing new work. So I'd always say, yeah, by all means, get young engineers in on your projects. Just don't let them run wild, because they may not know yet what good looks like, and they haven't experienced or may not have experienced the failure that some of the old hands have. And definitely, I'd like to say that every project I've worked on is a success. However, that's probably not the case.
Well, I think that takes us over the hour.
Oh, okay.
So, yeah, thank you everybody for dialing in, and we hope you enjoyed the webinar, and we hope you can join us on the rest of the series as we continue to explore the changing landscape of minerals processing projects and what this means for design, construction, optimization of those projects. Enjoy the rest of your week. Thank you.
Perfect. I would now like to bring the webinar to a close. So thank you, Matt, Andrew, and Duncan for taking the time and energy to present today. I'd also like to thank everyone who attended and those who are viewing the recorded webinar. I hope you found today's presentation insightful, and you'll join us, as Matt said, for the rest of the series. Thank you once again to the presenters.
Thank you.
And enjoy the rest of your day.